Hello everyone and welcome to this lesson about unit tests. So we're just going to go over what unit tests are and show a little bit of examples here. So what are unit tests? A unit test is a way of testing that your code is working as expected. So you write code and then you want to make sure that there's no bugs with it. So you write a test to make sure that it behaves the way that you expected. That way you don't have to go back and physically test or manually test that piece of code within regression. So we'll go over this in a bit. And it makes testing easier as it provides the developers and the testers more confidence that the code didn't break due to any change of logic. So since it's an automated test and it's already pre-written or you're writing it and it's automated, it means that you don't have to worry about something breaking, because if you write code that breaks that test, your test will let you know. I test a small component of the code to verify that the output or the function of the code performs as expected. So the key here thing is a small component. So really should be writing a test for one function, not for multiple functions, but for one function and a small function. So it gives you the worry-free ability when it comes to regression testing, as you're able to do less regression testing if you have high code coverage. Now you should still do regression testing, but with high code coverage, it gives you this worry-free ability. And then the unit test should have no dependencies on other systems or databases. And most of the time, better code coverage is better code. And then the visual tools available with Community Edition of Visual Studio for free is a tool that I like to use, which is called Find Code Coverage, which is a visual tool that just allows you to see the percentage of your code that's been covered, the lines, the covered lines versus the non-covered lines, and things like that. Now let's go back to this point right here. So with unit tests, you need to take out any dependencies that your program has on databases or things like that, because with your unit test, you don't actually want to go and make a call to your database. Your unit test should be standalone. So for this, we'll be going over how to mock your database so that you can remove that dependency. So here's how to add a unit test project. So within your solution, you should right click on your solution up here, scroll down and hover over new, and then click new project. And then this window will pop up, and what you'll need to do is just write unit test in here, and then select the unit test project in .NET Framework. So we're coding our application using .NET Framework, so you want to make sure that you do that. If you're coding your application in .NET Core, then select this one, and there's a few other options here for you as well. But we'll be selecting it in C# unit test project in .NET Framework. Then here, you'll want to give your unit test project the same name as a project that you want to unit test, but just do a period, add a period here after the name. So CS4 final _ Pista, which is the name of my project up here, and do .tests. So this will give you this will let you know that this is a test project. So here you can see that I have my unit test project over here, and my normal project is somewhere up here. And you can see that I want to test the order BLL class. So you can see that it's under BLL, and then the BLL folder, and then within it I have the order BLL.cs file. So in my unit test project, I want to do the same thing. I want to create that same type of structure. So if I want to create a test for order BLL, I need to first create a BLL folder, like how it is over here, and then put the order BLL file right underneath it. So here you can see that I have order BLL and then tests.cs. So if you're creating a test class, you'll want to just append the word tests in your class. So here, in order to create this BLL, this test right here, this test class, what you'll need to do is you'll first need to right click on this BLL folder right here, and when you right click, this menu will pop up. Hover over add, and you might or might not have this, but if you do, all you have to do is click on unit test. If you don't have it, scroll up and you'll see the new item here. So click a new item, and inside here, click on test, and then select the basic unit test. And then for the name here, remember to give it the correct class name. So for me, I'm doing order BLL and then test.cs. So just remember to give it a proper name. And this is what gets created. Here you can see that the naming of this text function is the function name. So here, let's go to my next screenshot. Here you can see that I created my own function. I created a function called myOwnAddition that takes an input of x and y and then does x and y, or x plus y plus 2. So this function adds 2 to the sum of these, to the sum of x and y. So here you can see that I'm testing that function, myOwnAddition. So the name of this function is a function name followed by the state, which is under the test, followed by the expected behavior. So on top of the function, I also have declared this to be a test method right here by adding this attribute to the function, and the test class attribute to the class. So test class right here. So these are required because the testing suite will not pick up these tests if you don't have them. So you can also see that I have arrange, act, and assert in here. So in plain terms, arrange is where you set up your test and you're getting everything ready for the test to actually happen. This could be setting up your classes, your objects, your mocks, etc. And then what act does is it actually does the test and returns a result. So in here you can see that I'm doing the addition and returning the result to the result variable. And then with the assert, you're asserting that the things that are returned are the way that you expect them to be returned as. So here I'm asserting that the result, when I pass in 0 and 0 to myOwnAddition, I assert that the result returned is 2, because 0 plus 2, which is what myOwnAddition does, returns 2. So we already talked briefly about this, but so this is myOwnAddition function. X plus y plus 2 takes in 2 parameters, x and y, and then it returns that result, plus 2. So here I renamed the function to be a little more precise in the name. You can see that here I kept the function name myOwnAddition, so it should always start with a function name. The state under test, which is it correctly adds 2. And what it will return, like what's expected. You can see that I'm doing 2 for x, 1 for y. For the act, I'm calling this class, and then the function. And then I'm asserting that the result is 5, because 2 plus 1 is 3, plus 2, which is what the function is doing, is 5. And here you can see that I am declaring my class up here, that I'm utilizing over here. So my class is up here, and then I'm initializing that class. I'm assigning that class over here. So my class equals new my class, and then if you remember here, this is this class where this function is at. It's called my class. So Visual Studio is going to execute every single test method, and then before the test method gets executed, it actually initializes the test. So let's say I have 5 test methods, right? In here, it'll execute test method 5 times. Right before every test is executed, it'll initialize it. So here we can see that this is where you can run your test, and it shows all the test methods that you have. So the first row here is a project name, followed by the namespace of where your test functions are at, followed by, so these two are namespaces, like the folders, followed by the class name, and then followed by the function, followed by the test function. So multiple test functions can actually be listed here if you have multiple tests in here. So this is just one test, but you can have many tests in here. This run button right here runs all the tests. So here you can see I have additional tests under here. And it'll run those, including this. And so if I run that, that's what will happen. If I select just this test right here, and I click run, it will it will execute um, only this test, this highlighted test. Now, if you don't have this Test Explorer on here, what you can do is go up to View in Visual Studio and then just click Test Explorer. And then this view should come up, and then I have it docked over here on the bottom. And then let's get back into this. So if you right click on, if you highlight one of these by left clicking and then you right click, you can run, you can select a menu option will come up here, and you can select run or debug. So this will execute only one of the tests that you have highlighted. So if you click run, it will only execute one. If you click debug, it will only execute one of the tests. Unless you have selected the class at the class level, then it'll execute all the tests within the class level, but it won't execute any of the other things. So setting breakpoints. So let's get into debugging. So setting breakpoints and running the tests won't break upon your breakpoints. It won't pause. So if you click run, let's say you set breakpoints on your tests because you want to see like what the outcome is, like right here. If you set a breakpoint and you click run, it won't work. So if you're having issues with your tests and you want to test them, you need to run your test in debug mode so that the application actually pauses on your breakpoints. And you can run the debug mode by right-clicking on your test or test that you want to debug and clicking the debug option right here. So here you can see, so I don't know if you have noticed, but I have this fine code coverage here. And what this does is it's a Visual Studio add-on, which is called Fine Code Coverage, which is free. You can find it if you Google it online. And it allows you to visualize your code coverage percentage and other useful information. So here you can see that I have code coverage of 89.8% of the lines in my orders BLL class. So here it is. You can see the percent that I have covered, and 100% covered in my my class class. So here's the my class, and it only has one function, and I showed you guys that I'm covering it, so it's 100% covered. All the lines are covered within it, and it shows you like right here I have 71 lines covered within my class, and I have a total of 126 lines in there, and out of those 126, 79 of those lines are coverable. So here you can see I'm covering 71 of those 79 lines, and I have 8 lines uncovered. Same here with the fine code coverage. You can see in total my line coverage for my project is 34%. So this is pretty bad. You usually want to get around like 80 or 90% coverage. The higher the coverage, the better. And here you can see that I added another function here. So I have the my own addition function that has 3 green blocks, whereas the my own subtraction function has 3 red blocks. So these right here, not these, but these right here. The green blocks indicate that they are covered by unit tests, whereas the red blocks indicate that those lines are not covered by unit tests or that are failing the unit tests. So I believe that there's also yellow blocks which indicate that some tests are covered but others are not, such as like an if condition if you're not hitting everything within an if condition. So this will help you in determining if you need to write additional test cases for those if conditions or not. So here you can see that I ran my unit test and it came back successfully. So it passed. It returned my expected outcome by adding 2 to whatever I submitted as my input. But what if another developer came and changed it to add 3 instead in the function without them knowing that our entire application relies on the secret addition of 2? What if they went in and they changed that to add 3, like so? So here you can see that another developer who wasn't me came in and changed the 2 to add 3. Now what's going to happen with my test functions? Because my test functions are making sure that it's adding 2. So here my test function is making sure that x equals 2, y equals 1. It adds it and it's returning 5 because 2 plus 1 is 3. plus 2 is 5. Well, if you ran this, after that developer makes that change, and they ran the unit tests, they would see that this test would fail because it's expecting it to add 2. So either some things need to happen here. Either the developer now needs to change this unit test to be 6, to return 6 in this condition, to fix this unit test, or they need to go back to their logic and understand why it was 2 to begin with. And if they indeed want to make it 6, they need to go into the code and see where else it's doing this expectation of being 2 and just change that to a 3 instead. So anyway, this allows us to catch this error early on, and it's automated, so we don't even have to think about it after we create this unit test. So anyway, I hope that this lesson about unit tests helped, and if you like this video, hit the thumbs up, and don't forget to subscribe for additional content. All right, everyone, have a good day. Bye.